Okay. All right, so today we're going to look at the Pythagorean identity, and we're going to work a little bit with radians and trigonometric equations. So first off, we're going to do a proof of the Pythagorean identity. So what we've got here is a unit circle, and from the unit circle, we can see that the coordinates of this point here are cosine of theta, comma sine of theta. So for our proof, from unit circle, A equals cosine theta, B equals sine theta. And then from Pythagoras' theorem, we can say that A squared plus B squared is equal to 1 squared. Inserting these two together, we get that the let me do it the other way around. We tend to write the sine one first. Sine squared theta plus cos squared theta equals 1. And this is the Pythagorean identity. So let's verify the Pythagorean identity for a specific value. This is going to give us sine squared pi over 3 plus cos squared pi over 3. This is our left-hand side. We need our table of values. So you want to get used to pulling up your table of values, your trigonometric table of values. Start it off over here, x. I'd always start off in degrees, and then I add the radians in. So then we get sine x, cos x, tan x. So this is a 0, a half, 1 over root 2, root 3 over 2, and 1. This is reversed. Root 3 over 2, 1 over root 2, 1 half, 0, 0. This is 1 over root 3, 1, root 3, and not defined. And we can add in our radian values. Now remember, with the radian values, you work this out if you don't memorize it exactly, from the idea that here is pi. So that makes this one pi over 2. We can cut this up into 3 spaces, 3 lots, so 60, 120, 180. So 3 of these, this means this is pi over 3, this is pi over 2. We can cut this up into sort of 4 segments, like this, into quarters, because these are quarters. 45, this is pi over a quarter. So 30 is the half of 60, that's pi over 6. This is still 0. So these are our trigonometric values. You need to figure out how to pull this up fairly quickly so that you can use the values. We've got pi over 3, so we're focusing on this part here. That's going to give us sine is root 3 over 2. So this is equal to root 3 over 2 squared plus 1 over 2 squared, which is equal to 3 over 4 plus 1 over 4, which equals 4 over 4, which equals 1, which equals the right-hand side. And we verified the Pythagorean identity. Okay, so one of the most important things we do with the Pythagorean identity is we find cosine and other trigonometric values given one particular trigonometric value without going through finding what the angle is. And it's a fairly common and standard routine that we use in trigonometry. So the Pythagorean identity gives us that 3 over 5 squared plus cos squared theta is equal to 1. We insert this value. This tells us that the cosine squared of theta is equal to 1 minus 9 over 25. That's 25 minus 9 over 25, which is 16 over 25. And this is the cosine squared of theta. This implies that the cosine of theta is equal to plus minus 4 over 5. Now, what we then need to do is there's usually something else in the question that we have to sort of consider to see which values we'll accept and which values we won't. We're told in the question that the angle theta is in this interval. So you have to think a little bit about the unit circle and where the sine and cosine values are positive and negative. So we're given the idea that the sine of theta is equal to 3/5. That's this line here. So this is the line y equals 3 over 5. And our angle that we're talking about is this one here or this one here. These are the two angles which will give the value. So whether we're talking about theta being in the first quadrant or the second quadrant, the sine value can be positive. Now, if the sine value is positive in this interval, the cosine value can be both positive and negative. So this gives us two possible answers, and both answers are acceptable in this case. The cosine value can be positive and negative in that interval. Here is 0, here is pi. Have a go at this one for yourself. Pause the video at this point. Have you paused? Told you to pause. All right, welcome back. So let's go straight into sine squared theta plus 5 over 13 squared is equal to 1. Rearranging that, we get sine, zoom in a little bit, sine squared plus, move it to the other side. I'm going to get 25 over 169. So I'll immediately turn this into 169 over 169. If I do the subtraction, I get 144 over 169 is equal to sine squared theta. This implies that sine theta is equal to plus minus 12 over 13. Now, got to do some unit circle. Like that. So we've got a cosine value of 5 over 13. That's this one. And our interval is minus pi to pi. So our interval is going from here around to here. This is pi. This is minus pi. It's somewhere in this interval. So the two values that we can get is this value down here, which is a negative value, and this value, which is the positive value of the same number. So in this particular interval, the cosine value is in the first or fourth quadrant, and it would be the corresponding sine value would also be positive and negative. So both of these axes are acceptable. Find the cosine of theta given that tan theta. Ooh, okay, so this one gets a little bit trickier now, and we need to pull on another formula. So remember that sine, let me just try and make my pen a bit thicker. I don't know, maybe. Let's see. So we need to pull on the formula sine theta over cosine theta equals tan theta. This implies that sine theta equals cosine theta times tan theta. So that tells us that sine theta is equal to minus 3 over 4 cos theta. We can use this equation, substitute it into the Pythagorean identity. Not iPad savvy. Okay, so we've got, so from sine squared theta plus cos squared theta equals 1, inserting everything that we've got, we can say that minus 3 over 4 cos theta all squared plus the cosine squared of theta equals 1. Expanding that, we are going to get 9 over 16 cos squared theta plus 1 cos squared theta equals 1. So adding these two together, that's going to give us, 9 plus 16 over 16 cos squared theta equals 1. Let me just show you what I'm doing there. I'm adding in here at this point that this is 16 over 16. So 9 plus 16. We need to rearrange this. I get cos squared theta. I can rearrange this. If I multiply both sides by 16, that'll come here. If I divide both sides by 25, that'll come down here. Can then take the square root, and I get cosine of theta equals plus minus 4 over 5. Right, I'm not finished yet. I've got to think it all through with the information given in the question. I am told that theta is between 0 and pi. So let's start off with our unit circle. Oh, look at that, getting better. We are told that the angle, let me do some shading this time on that one. The angle is between 0 and, so the angle is here. But the tangent value is very clearly negative. So the angle is here. The tangent value is negative in the second and fourth quadrant. It's positive in the first and third quadrant. So we can tell by the information given in the question that the angle that we're after is in the second quadrant. So if the angle is given in the second quadrant, then the cosine value has to be negative. So as theta is in the in Q, quadrants are given in Roman numerals like this one. As theta is in Q2, it implies that cos theta is equal to minus 4 over 5. And this is our answer. Let me make that a bit more visible in case you want a single screenshot. I got a bit small there at the end. All right, there you go. Okay, let's move on. So just to remind you about solving equations, this little table of values, I included this one here because it's very useful to help you when you're doing equation solving. We've seen the degree version before. This is when theta is in degrees. If theta isn't marked as being in degrees, then it's assumed to be in radians. Whenever you're working with functions, whenever you're working with derivatives, whenever you're working in most settings, we always assume that the angles, trigonometric values are in radians. Only geometry do we tend to use degrees. So we use it if we're working with triangles and geometry like that one. We're working with bearings, architecture, anything sort of real in that kind of respect. We tend to work in degrees. If it's functions modeling, we're using radians. Any calculus involved, always radians. You'll see that next year, hopefully. All right. So you can see in this question that we're in radians. So your answer has to be in radians. The equation is defined in the limited domain of 0 to 4 pi. Your answer has to be in radians. So we've got an equation to solve. Let's look through this equation. How can we solve it? So when you're solving an equation, you'll be introduced to a variety of different techniques, and you've got to stare at the equation for a minute or two and think, well, which approach should I use? Typically, your approach is to eliminate all of the trigonometric values, all the trigonometric functions other than one. Looking at this function, I'm going to eliminate everything other than sine. I want to rewrite the entire equation in terms of sine. This will let me solve it. I can do that by tackling that cosine squared with the Pythagorean identity. So that's where I'm going to start off. So I've got 1 minus, let me just do the Pythagorean identity. Sine squared theta plus cos squared theta equals 1 implies that the cosine squared theta is equal to 1 minus sine squared theta. I can insert this into the equation to give 1 minus 2 bracket, and then I've got 1 minus sine squared x, because this is in x. So I'm using theta in the identity to make it separate from the x here in the actual equation. And then I'm in terms of x now. Expand the bracket. I've got 1 minus 2 sine squared x minus sine x equals 0. Let's bring that over to the other side. I've got 2 sine squared x plus sine x. On the left-hand side, I'd have minus 1, so that's going to be plus 1 here. Everything's negative, I don't like that. We move over there. Then I'm going to factor. So you've got two techniques for factoring an equation like this. When you just factor it straight off. What some people like to do is to let t equals sine x and do a substitution. So this would give us equals 2t squared plus t plus 1. You see the quadratic. Some people can work with the quadratics directly in terms of sine x. Other people like to do the substitution and then move back again afterwards. So we need to split that middle term. We've got 2, so we need plus 2 and minus 1. So this is going to give us 2t squared plus 2t minus t plus 1. Split that middle term there. Factor, pull out the 2t. If we pull out 2t, we're left with t plus 1. For the second one, That's not going to work. That's not going to work because... Where have I gone wrong? Where have I gone wrong? Let me just check back. I've gone wrong somewhere. So I'm trying to find where my mistake is. I'm back to this point here, checking it through. There, I spotted it. Okay. This is the disadvantage of not having you guys in class to check everything. When I expand the bracket, I'm doing -2 times 1, giving me -2. -2 times sine squared. This should become positive. So I've got a positive here. That means I want to trash this. I've got 2 sine squared x minus sine x minus 1 equals 0. So I'll do my variable substitution. 2t squared minus t minus 1 equals 0. I've got 2t squared minus 2t plus t minus 1 equals 0. 2t bracket t minus 1 plus t minus 1. I've got 2t plus 1, t minus 1, t equals minus a half, t equals 1, sine theta equals minus a half, sine theta equals 1. A little quick draw of a unit circle, don't catch any more errors. So sine theta is equal to a half is giving me a solution here and a solution here. This one is similar to the solution in the unit circle that we see here when it's equal to a half. So as we saw in our exact value table, sine theta equal to a half is this one, pi over 6. So this is pi over 6. So this is minus pi over 6. Here we've got a pi over 6 rotation. So this is 6 pi over 6. So this will be 7 pi over 6 here. This one can also be written as, this is, if it were full rotation, that's 12 pi over 6. So this is 11 pi over 6. So those are my two solutions there, 7 pi and 11 pi over 6. So theta is equal to 7 pi over 6, 11 pi over 6, plus n 2 pi. Sine theta equals 1. That is going to be here at this point. That's pi over 2. So theta is equal to pi over 2 plus n2 pi. These are all of the solutions to the equation. We have to go back and find the solutions that come in the interval of the first two rotations. So we need 7 pi over 6. I'll start off with pi over 2, and then 11 pi over 6. These are the first rotation. Then through to the second rotation, I can write this one like this one, plus n 4 pi over 2. So that gives me 5 pi over 2. And on this one, I can write this as n 12 pi over 6. So I'm adding 12 to each of these solutions. So 7 plus 12 is 19 pi over 6. 11 plus 12, that's 23 pi over 6. And these are all of my solutions. Just fix some of my math language. I switch to theta there. This is sine x, x equals this, x equals this. This is the set of values of x. Okay, if you want to take any screenshots like that. Okay, have a go at this one for yourself. Pause the video now. Okay, let's have a look at a solution for this one. So we can see that it's all written in one variable. So it's going to go straight in and solve it in terms of tan. We've got, we can probably factor this. The factors of -2 or -2 times 1. So -2 times 1, so this gives tan x minus 2, tan x plus 1 is equal to 0. Let me just check that. Yep, that looks good. This tells us that tan x equals 2 and tan x equals -1. So remember that sine and cosine have to be between -1 and 2, but tangent doesn't. Tangent can be any values. So I'm going to need my calculator for this one. I need to do the arctan. So on my calculator, let me just... do my calculator to somewhere. Make sure I'm in radians, yeah. And then I want the arctan of 2. So x equals 1.11 plus n2 pi. Nope. Plus n pi. And -1. I've got the calculator for this one, so you can do that one without the calculator. See how it looks. So x equals minus pi over 4 plus n pi. We need to get all of the ones in the first interval. So on the unit circle, our first angle is going to be up here. And that will have a corresponding one down there. Our second angle of -1 is going to be up here, and I'll have a second angle down there. So we'll get one in each of the 4 quadrants. So on my calculator, I'm going to take that value and I'm going to add pi to it. So we get 3 pi over 4. That's this one here. No, that's this one here. We get 1.11 first. Our next one is going to come from this value, and then add a pi to it. So 4.25. And then we need this value up here, 7 pi over 4. All right, those are our values. Classwork and homework, work with IXL BB4, and I've got some questions for you to work with as well today. All right, that's it.